let's talk about parallel and perpendicular lines. So if I have this line, remember how to write our equation. Y equals m is our slope. We're going up 1 and over 1, up 1 over 1, up 1 over 1. So we'd say our slope is 1 over 1, or just 1. X plus our y-intercept, which here in this case is plus 3. What if we were asked to translate this line down 2 and over 3? So what if they asked us to make a transformation to go down 2 in our y direction and over 3 in our x direction? X plus 3 and y minus 2. So each point I'm going over 3, 1, 2, 3, and down 2, 1, 2. And I don't have to do it with each point over 3 down 2 because I know my slope, right? My slope is 1 over 1, so I can go up 1 over 1, up 1 over 1. So now we have our new line. If we were to rewrite this, we still have the same slope, right? Our rise or run didn't change. But now our y-intercept, right, got shifted at -2. So notice that our lines are parallel. You can kind of think of them like train tracks. In geometry, we use symbol to show that lines are parallel. Sometimes you see them slanted as well. I think in your derivative assignments, you'll see it look like this. But this means parallel. And if lines are parallel, they will never cross each other, and they have the same slope. Our slope is the same, and that is why they'll never cross into each other. You can translate this line as much as you want, right? You can have a different rule and they will never run into each other because the slopes are the same. So what if we did x minus 7 and y plus 3? That means I take this and I shift it left 7 and I shift it up 3, right? But then if I start my rise or run again here, 1 over 1, I'm going to have a new line that is also going to be parallel with these lines, just with the new y-intercept.
All right, so now we are going to take a look at this line here, y equals 3 over 2x plus 1. It's graphed right here for us, and we want to rotate this line 90 degrees clockwise. That's what this little arrow means, about 0.01. And what that means is we're going to look for the 0.01, which is our y-intercept right here. It's over 0, up 1. We want to rotate it about this point. So this point is going to be the center of our rotation, okay? We're going to take a couple points on this line, and we are going to figure out how far away they are from this point, because this is the point we want to rotate it about. And so if this is our original direction, up is right there, we want to rotate it 90 degrees. So we want our new direction to be going this way. So if we look at the center of rotation, how far up and over do I have to go to get to my next point? Well, I have to go up 3 and over 2 to get to this point right here. So I'm going to go, if I flip it this way, I'm going to go up 3 and over 2. And this will be a new point on my rotated line. Okay. And then if I come back to my center of rotation, I now have to go up. I'm at 1. I go to 7. I had to go up 6 over 4. So I'll come back here. I'm going to go up 6 over 4 right here. Okay. And I only need 2 points to draw a line. So we're going to draw this line. All right. So now I have my new line drawn right here. Okay. So we're going to write the equation of this line. It's going to be y equals, and so let's figure out what the slope of this line is. This point right here, I have to go down 2 over 1, 2, 3, down 2 over 3 to get to my next point, and I can draw another slope triangle here, down 2 over 3. So my slope is going to be -2 over 3x, and then it still crosses at the same y-intercept, so plus 1. Okay? If we look at these two lines, when we rotate a line 90 degrees, it creates something called a perpendicular line. And what a perpendicular line is, it's when two lines cross at a 90-degree angle. So this angle right here that the two lines make is 90 degrees. And that's true for each part where they cross. Now, if we come back to our equations and we look at the slopes of these lines, we can see how they relate. So our original slope of our original line was positive 3 over 2. The new slope of our new line is -2 over 3. So we can see how our original line was a positive slope and our rotated line is a negative slope. So we knew that that part was going to be different. And then if we look at the fraction of our original slope, it's 3 over 2. And then we look at the fraction of our new slope, it's 2 over 3. When you have two lines that are perpendicular, they cross at 90 degrees. And another way that we represent that is with this symbol, an upside down T. And we'll write that over there so you guys can remember. That will be on your derivative assignments. When we have a perpendicular line, we know that the slopes are going to relate to each other by being the opposite reciprocal. And that means that if it was positive, it's then going to become negative, and reciprocal, if you remember from a couple videos ago, is when we flip the fraction. So the opposite reciprocal of 3 over 2 is -2 over 3.
Now we're going to talk about how to write parallel lines and perpendicular lines given an equation, and you don't need to graph it now that we know things about parallel and perpendicular lines. So if your assignment asks you to write a line that is parallel to this equation, y equals -7/3 x minus 3, we know for parallel lines that they never cross each other and they have the same slope. So I can write literally any equation I want. Y equals -7/3 x plus, this could be any number. So this could be plus 123, whatever, it doesn't matter. This will be parallel with this if I were to graph them because my slopes are the same. What if I had a perpendicular one? Remember that perpendicular lines cross at 90 degrees and our slopes are opposite reciprocals. So opposite means they have the opposite sign. So because this is negative, I know that my perpendicular line will have to be positive. So it'll be a positive slope. And the reciprocal means I invert my fraction. Instead of going down 7/3, if we were to rotate ourselves, we would go over 7, down 3 instead. So we would say that this is positive 3/7. And again, the y-intercept can be literally whatever. I'm going to say -52. It does not matter unless it specifically asks you to have a certain y-intercept. But this is a perpendicular slope because it is the opposite sign and the fraction is flipped or the reciprocal.